So Prim's algorithm is again a kind of a minimum spanning tree, but there is a difference between Prim's algorithm and Kruskal's algorithm. Unlike Kruskal's algorithm, Prim's algorithm grows in a successive stage. So we do not randomly pick the node which is in the ascending order and keep on adding to the minimum spanning tree. Rather, we are going to follow a successive stage, a successive steps rather. So at any stage, we can start from any particular node. Unlike Kruskal's, we need to take a particular node, and using this particular node, we can keep on completing the visiting of all the vertex unless and until all of them are included. And we will go through the algorithm step by step. Before that, this is the brief introduction. So this algorithm always find a new vertex to be added into the tree after choosing the minimum edge vertex from that particular node to the adjacent nodes. And whenever you are identifying the minimum edge node, you simply add it to the set of vertex, and that edge will be included in the set of edges unless and until all the properties of minimum spanning tree is completed. So let's take an example. So you can consider this graph, and in this graph we are having 7 vertices and we are having certain edges. And from this particular graph, it may be given that start the Prim's algorithm from, let's say, V5, V3 or V1. So whatever vertex is given, you start from that particular vertex and then you complete all the properties which is required to complete the minimum spanning tree. So here we have completed this minimum spanning tree by taking the node V1. You can either take V4, V6, V7, whatever is given to you. But here we are starting with V1. What I need to do is I'm going to create an array of visited node, and I'm going to create a set of edges which is going to be filled step by step. So with this particular graph, we start with the one vertex, that is V1. Now starting with V1, what we are going to do, we are going to create this particular array. We call this array as selected. You can just take a snap of this particular graph so that you can refer it again and again, because we'll be scrolling down through the next page. So for the understanding, you can take the snap so that we can move further. Okay. So what we are going to do is we are going to start with V1. This is considered as a source vertex or the start vertex, and this is added into a selected array V1. Now from this V1, I need to identify all the edges which is adjacent to it. So from V1 we have V2, V3 and V4. The weight from V1 to V2 is 4. The weight from V1 to V4 is 2, and weight from V1 to V3 is 5. So I need to select an edge with minimum weight. So we are going to select the minimum weight edge, and that edge is V1 to V4. So you can see that we have an edge. This is simply a set of the edges that we are going to select. So we have selected V1 to V4 because this is a minimum weight edge. And now whatever edge you are going to add into this particular edge set, you take both the vertices and add it to a new selected array. So V1 was already there. Now we are adding V4 because the path from V1 to V4 is considered. You can see on the right hand side, we are simultaneously completing the minimum spanning tree. So we have taken this edge V1 to V2, the weight is 2, and V1 and V2, both the vertices are added into the selected vertex. Now I need to identify that what next edge is to be selected, but I cannot take randomly any particular edge. Rather, the edge has to be selected from either V1 or V4, that is the vertices which is present inside the selected array. So inside the selected array, you have V1 and V4. You can look for the edge from V1 and V4. So adjacent of V1 is now V2 and V3 because V4 is already considered. And identify the adjacent from V4. We have V5, V7 and V6. So from this, we are going to select the minimum. So from V4, we have V2, V3, V5, V6 and V7. The minimum edge weight is from V4 to V2. So we will select V4 to V2, add this edge into the edge set, and we will add V2 into the set of selected vertices. So from V1 and V4, you need to identify the minimum weight edge. So minimum weight edges from V4 to V2. So we have included that edge into the edge set. This is the next step of the minimum spanning tree. V1 to V4 was already there. Now we are going from V4 to V2. Now we will add V2 into the set of selected vertex. Right, so consider that the weight from V4 to V3 is 7 because it is not visible in the graph that we have seen. So we will proceed further. Now from these three vertices, that is V1, V4 and V2, identify all the adjacent edges and identify the minimum weight edge. So now you can directly see that from V2, I have an edge from V2 to V5 and the weight is given as 2. So we are going to consider that particular edge. We will add V2 to V5 into the set of edges. Simultaneously, we will add V5 into the set of selected vertex, and we are going to draw the next step, that is an edge from V2 to V5. Again, we have to select the minimum weight edge. So here, if you analyze this graph one more time, you can see that the next minimum edge is from V5 to V4. But here we have already selected V4 to V2 and V2 to V5. And when you select V5 to V4, this is going to create a cycle, and this is violating the property of a spanning tree. So remember that in case of spanning tree, the property is a cycle should not be there, all the vertices should be included, and the number of edges should be equal to number of vertices minus 1. So just because there is a cycle, we are not going to consider V5 to V4, and therefore we proceed and select the next minimum weight. So the next minimum weight is from V4 to V6. The weight is 4. We include this edge into the set of edges, and V6 will be added to the selected vertex. So here you can see that now V6 is also added to the selected vertex. Simultaneously, we are completing this edge from V4 to V6. So now from the set of selected vertex, identify the next minimum edge. So you can see that the next minimum is from V6 to V3, and the weight is 1. Complete this graph. We are going to add V6 to V3, and the next edge to be added is V6, V3, and therefore on the right hand side you can see that we have added V6 to V3 into the set of edges. So now this is your minimum spanning tree, right? We are left with one more particular vertex, that is V7. So identify the next minimum edge from V1, V4, V2, V5, V6 and V3, right? So the next minimum edge that you can see is from V6 to V7, right? So the next is from V6 to V7. Add this V6 to V7 into the graph, and the total weight here is 6. So at the end, this will be the minimum spanning tree, and if you calculate the total weight, this will be equal to 16. So this is how the Prim's algorithm works.